Coming over here, maximization problem, okay? And I told you already what is the maximization problem, am I correct? So now in this particular video, I am going to solve a maximization problem, okay? Now the given problem is a maximization problem. So in this particular problem, there are 4 districts, 4 salesmen are there. We have to send to the salesman to different districts so that the total cost is very maximum. Not total cost, total profit is very maximum. That is what we have to find out there. Okay, now how we can change this maximization problem into minimization problem? Okay, maximization problem into minimization problem. I told you that choose the very high entries here. The very high entries is 16 here. You subtract all our entries from this 16. You will get this particular box. Am I correct? 16 minus 16, 0. 16 minus 10, 6. 16 minus 14, 2. And 16 minus 11, 5. You will have 16 minus 14. You will have 2. 16 minus 11. You will have 5. 16 minus 15. You will have 1. 16 minus 15. You will have 1. You do like that. Subtract all these elements from 16. You will get this. Now this maximization problem becomes a minimization problem. Okay, right. Now already we know that how to solve the minimization problem. Am I correct? Now first one is what? Row wise reduction. Second one is what? Column wise reduction. Third one is what? Drawing the lines. And last one is what? Best assignment. Okay. Now let us see one by one. Now the maximization problem becomes a minimization problem. How? By choosing the maximum number from the left side box 16 and subtract all other entries from this 16. This is very important. Subtract all the other entries from this maximum element here, that is 16. So we will get this problem. Now it becomes a minimization problem. Yes, very good. What's the next step? Row wise reduction. We have to take each and every row which is the least element, then you subtract that element from other element. Least element, subtract that element from other element in the corresponding row. In this least element, subtract from the corresponding row. In this least element 1, subtract from the corresponding row. In this least element, subtract that from this corresponding row. What you will get? This you will get 0, 6, 2, 5, 1, 4, 0, 0, 0, 0, 2, 3, 2, 3, 1, 0. Okay. Now we have to come for column wise. Okay. So what's the least number column wise? 0. Subtract the 0 from all these elements. You will get first column in the third step. Similarly, what is the least element in the second? 0. So subtract that all the elements from subtract 0 from all the other elements in the second column. You will get the second column in the third step. Similarly, third column and fourth column. Okay, so this is column wise reduction we say. What we say? Column wise reduction we say. Now come to this particular step number 4 is drawing the lines. Through maximum number of zeros we have to draw the lines. Okay, you take 4 0 occurring rows or columns. Here no 4 zeros anywhere in any rows or any columns. Am I correct? Second one is 3 0 occurring rows or columns. 3 0 occurring rows or columns. Okay, so now there is no 3 0 occurring rows or column. Am I correct? So only 2 0 occurring rows are there or columns are there. Okay, so now what I am doing there, second row 2 zeros are there, I am striking out, that is number 1, line number 1. Then the second row consists of, third row consists of 2 zeros, therefore that I am striking out. Now I am taking this as line 2. Okay, right. So 2 zeros occurring rows and columns are over. Now after that what? 1 0 occurring rows. So where 1 0 occurring rows, the 1 0 occurring rows is first one, we can strike out that, or column wise also, that is third line. Similarly, the last row consists of only 1 0, so that column also we can strike out. So totally how many lines we can get? 4 lines we can get. Okay, 4 lines we can get. That is, we can draw through maximum number of zeros. How many lines we can draw? 4 lines we can draw. But the given matrix is what? The given matrix is 1 2 3 4, 4 by 4. Am I correct? So the number of lines is equal to 4, and the number of that is order of the matrix also 4. Number of lines equals order of the given matrix, that also 4. Therefore optimum is assigned. I mean optimum stage have been reached. Optimum condition is satisfied. Now step number 5. After drawing the lines, we have to choose only 0 occurring boxes only. 0 occurring boxes only we have to take into account there. Okay. So on the step number 5, you are seeing a box or matrix where only 0 occurring boxes are taken into account. Okay, that comes the first row, first box, second row, third box and fourth box, fourth row, first box, second box, last row, last boxes. Okay, right. So now you have taken this into account. Now this is a very important step. We have to assign such that each row has only one assignment and each column also should have only one assignment. Why? Because each salesman has to go to only one district, or one district should be assigned to only one salesman. That means what? Each row should have only one assignment and each column should have only one assignment. Okay, so that is what our aim here, and we have to assign according to that. Okay, right. You take the first row there, only 1 0 is there, so you assigned that by 00 there. Okay, if any other zeros or columns are coming there, we have to strike out. Okay, then we have to go. So I have assigned the first salesman to the first district. Now come to the second row. So before that you have to understand one thing. I have assigned first salesman to the first district. Therefore I have assigned the first box in the first row. If any other zeros are there, you have to strike out. Okay, in that row no zeros, so we need not strike out any zeros. But now come to the column wise, 1 0 is there on the third row first box, so that we have to strike out. Okay, if any other zeros are in that column, that also we have to strike out. Then only the meaning is that one salesman is assigned to only one district. Okay, right. So first row assignment is over. Now I am coming to the second salesman assignment. The second salesman assignment, I have 2 zeros in the second row. In the last 2 boxes 3 zeros are there. Okay, now what I am doing there, I am assigning the first box, that is second row, third box I am assigning. If I assign like that, then what are the other zeros are there in the second row, and in the third column I have to strike out. Okay, so in the second row the last box also I strike out, and I am seeing in the column wise third column, and the third column there is no other zeros are there, therefore I need not strike out any zeros there. So second row you see there only one assignment, and third column only one assignment. Now come to the third row. Okay, the third row already the first box is strike out, the second box I am assigning that. Okay, right. So now last one, last column I am assigning. Now what I am getting? I am getting a best assignment as given in the screen. The first salesman to the first district, second salesman to the third district, and third salesman to the second district, and fourth salesman to the last district. If do so, the maximum profit we will get is 16 plus 15 plus 15 plus 15, we will get 61. So this you have to get from the given matrix. Thank you.